We've been doing some videos on scientific notation and how to work with big numbers, how to write scientific notation for really small numbers, but what are some of the things we can do with scientific notation? How do we do like multiplication and division when we've got scientific notation involved? So let's have a look at some examples. What if you were asked to calculate this? Now you'll see these two numbers are both written in scientific notation. 2.3 times 10 to the 3 times 3.1 times 10 to the 7. So I've got a scientific notation number here and another one here, and I'm multiplying the two of them together. So here's a little trick or a little key to what's going on here. These are all just multiplications, and it doesn't matter what order we multiply things in. 1 times 2 times 3 is the same as 2 times 3 times 1, or 3 times 1 times 2. So we can shuffle, or we can readjust the order. And that's what I'm going to do with these numbers. These four pieces, this decimal, the 10 to the 3, this decimal, I'm going to reorder them because it doesn't matter. They're all being multiplied. And I'm going to put the decimal parts up front, and I'm going to put the index parts up the back here. So the reason I'm going to do this is now I've got these together, I'm going to call upon my understanding, or hopefully I can remember index law 1 that says when I multiply things that have the same base, I add the indexes. So my 10 to the 3 times 10 to the 7 becomes 10 to the 10. And that was index law 1. If you're not sure, if you can't remember that, I've got a video on that. Go and track it down, or search anywhere on YouTube somewhere. You'll find index law 1. So I've now tidied up this part. So what leaves me with it leaves me with these front decimals. Now I can just use my calculator and multiply those two numbers together. Right? It turns out to be 7.13. This bit hasn't changed, the times 10 to the 10, so I've written that now in scientific notation. I've multiplied those two things together. I've used my index law to tidy up the 10 to the power ofs, and I've just multiplied the decimals together. Right? So I can actually do that and get this nice, neat answer. All right, let's apply this to a question. Space probe has been launched to travel to Neptune. There's our distance. It's in scientific notation. How long, if its average velocity or its speed, is that number in scientific notation? This one up here. Let's see if we can get that. Okay, I'm going to round it off to the nearest 1,000 hours. So I am going to use my distance, speed, and time to work out that my time is going to be the distance divided by the speed. Okay, so however far the distance is, I divide it by the speed, that will tell me how long the time was. So those two numbers were given to me in scientific notation. This time, instead of multiplying them, I am dividing them. So that's what a fraction is. It's the top divided by the bottom. Now, similar to what we just did, I'm going to readjust everything. But before I do, I'm going to divide the coefficients. So I'm going to do the 4.31, and I'm going to divide that by 2.5. And when I do that in my calculator, I get this. Now, what am I left with? 10 to the power of what? Well, I've got 10 to the 9 divided by 10 to the 5, looking at my question here. And index law 2 tells me that when I divide things that have the same base, I subtract the indexes. So my result will be times 10 to the 4. Okay, so I've got two numbers in scientific notation. Those steps again were just simply, first of all, divide the decimal parts, the coefficients, right, and then use index law 2 on the base 10 parts, the 10 to the power of whatever's. Okay, that gives me, this is my number. Okay, it's blah blah blah. It's sorry, if I move the decimal point 4 places to the right, let's just go back and do that bit again. Right, that is my number. If I write the 1.724, and to write it as a normal numeral, I move the decimal point 4 places along, because that's what we do with numbers that are more than 1. 17,240 hours, rounded off to the nearest 1,000, gives me 17,000 hours. One last one. If light travels at 3 times 10 to the 8 meters per second, how far will it travel in 1 minute? Well, there are 60 seconds in a minute, so I can take my speed per second, multiply it by 60 to work out how far it goes in 1 minute. Now let's have a look and see what we can do here. Multiplication, I can do in any order. So I'm going to take the 3 and the 60 and multiply them together to get 180. Now, that is not in scientific notation, because remember, for scientific notation, we always have to have the decimal point after the first digit. So my decimal point is currently here. It's at the end of the 180, and I'm going to move it between the 1 and the 8. So let's do that and see what this would be, just this 180 written as scientific notation. So I'm going to move it 2 places along. And so what I've done is I can write 180 in scientific notation as 1.8 times 10 to the 2. So I'm going to replace that here. And now I've got 1.8 times 10 to the 2 times my 10 to the 8 from the first part. And I can see again, once again, using index law 1, I've got bases that are the same being multiplied. So I add the indexes. Now it is in scientific notation because I've got a decimal after the first number. And my answer is that number in meters per minute. I know there's a lot going on there, so feel free to pause, rewind, have a look through what we did, utilize those index laws, and we can play around with these big numbers and have some real fun with them. Okay, well done.